Pa dobro večer svima, but this time we're going to speak in English. So good evening to everybody. We're going to present today Stefan Saftic. He's going to be our speaker on MLOps for architects. With us today is Jenan also. Jenan is AWS community AWS community hero and also AWS user group leader for Bosnia and Herzegovina.
Hello everyone, good evening.
Yes, good evening everybody. I guess we're gonna wait a few minutes because the people are joining. So
yeah, cool.
Stefan,
let's wait.
Stefan, how is in Germany?
It's very hot currently, so it's a lot sunny after many rainy days, so can't complain about that.
Okay, cool. Very nice.
How is it in Budva?
In Budva, it's very warm. It's a bit humid for this period, but it's very warm. And basically season already started, so people are swimming. You know, it looks like a July, honestly, but it's still May, actually. Okay, almost first day of June, but still May. So yeah.
For 5 more hours. Mari, maybe because this is a meetup on English and we have probably some auditorium outside of the Balkans region, maybe you should use this opportunity to introduce AWS User Group Montenegro to say a bit about the activities and so on.
Sure. Thanks, Jenan. Basically, we're based in officially in Podgorica. Me myself, I'm based in Budva, and we started in 2019, just after the reInvent, and in that moment we had around 50 members, and we organized the first meetup in I believe it was end of December, and it was with Darko. Darko visited us and also basically helped us to arrange this first meetup. From then on, unfortunately, we faced pandemics, and because of pandemics, we were basically we just couldn't have the meetup, so we turned everything online. So all the meetups that were happening next 2 years were online. We also had a hackathon. It was actually not a hackathon, but it was like a startup league where we had teams working on projects, and the idea was to build something in serverless, and basically we then together applied for some funding by Intel, and some of the teams succeeded to get some funding. So that was very interesting, and it was great. Basically spend time for learning AWS serverless services, and also I mean, in lockdown, what else can you do? So it was I think well spent time. So yeah, that's pretty much it. I believe we had around 12 meetups, and there will be for sure more, and we are also thinking of creating some bigger events, but we are gonna tell about those events in the future when there are some more news regarding that. We'll see. We're organizing it. So we'll let you know.
Cool. Thanks. Basically, this is like a repeated event because last week you and Janana and Stefan, you had a meetup with exact same subject, but it was on Serbian language. Stefan is from Serbia and working in AWS office in Munich, or where is your office, Stefan?
So I'm actually virtual located, but if it will be the office, it will be the one in the Düsseldorf. That is the most closest one to my place. And for all the folks that don't speak what we call local languages in the Balkan, this is why we're doing this in English. So.
And it was quite a big interest, and a lot of messages arrived about with the questions, can we have it on the English? But well, we at Balkans AWS user groups, we are trying to bring AWS closer to the everyone interested into the AWS located on Balkan regions. So we are more eager to have events on our local languages, but it's also great to have this kind of international event. So yeah, let's do it in English. And also thank you, Stefan, for joining us tonight. Last week in front of the AWS community Bosnia, my sister Janana was there to lead an event together with Marin. Tonight she was not able to join us, but well, I hope she will she will watch recordings after.
Thank you for having me.
Marin, you have some kind of the hybrid event where you have people on site watching this.
Yes, absolutely. So we're organizing this in the IT hub in Budva. So we're having a few people, and there are people joining also, even some kids. So it's gonna be interesting. Yeah. So yeah, let's see how it goes. I think 8 minutes passed, so I think we should start.
Yeah, sure. Okay. So then, let me first introduce myself. So my name is Stefan Saftic, and I'm solution architect at AWS. And today we are going to go through end-to-end MLOps for architect session, where the idea behind is that you will get knowledge more around what type of architects or architecture you can expect when it comes to MLOps. This should not touch much on the ML side, but more on the operational side of ML. So anyone with I would call DevOps skills should be able to follow through. Having said that, just to briefly cover what we're going to speak today. First, we are going to discuss about the challenges that many corporations are facing when they're trying to operate ML models. And then we're also going to touch up actually what is actually the MLOps, as the term itself has multiple meanings for different people. And then after that, we are going to go to 3 different MLOps architectures. I made them in t-shirt sizes, so it comes from S to L, which is actually fitted for different type of teams or projects that you have at the moment. And of course, in the end, I prepared some articles and links for you so that you can start your MLOps journey. So maybe let's start first with what is machine learning, right? So first, we have some business problem that we identified that machine learning is actually a good solution for it. Then after that, the data scientist would actually take a lot of time to do a data collection, then integrate with various other data, prepare it, cleanse it, and by the end, have some analysis and visualization of that data. So after all of this is done, and this approximately take around 80% of the time of the whole project, so it's quite a big timely task to do. After that, the data scientist would go and do the feature engineering, Of course, with some parameter tuning, choosing the model, and by the end evaluating, it would go and assess or are all the business goals met with this. In case it's not, it might be that it needs further feature engineering, or maybe we are missing some crucial data for the business problem to be solved. So this is why we say 80% of the time is spent there, as data scientists really need to validate until we have all of our business needs. In case our business needs are met, in that case, data scientists would actually go and do a model deployment. Of course, we will have some type of interface, which will have predictions. And after that, what is also really important, and most of the time we just forget about it, is actual monitoring and debugging of the model that is in production. So just to explain it, after we train the model, we can literally think about it as it's a new car that we just bought. The value will just start dropping. And it's the same with our model. So from the moment we actually build that model, because of there is like a lot of changes happening in the world, right? And especially with the data, it might be that as in a week, our model is not any longer relevant. And we really want to actually monitor this and to be able to get this information before our customers and users are actually starting to see that the model is not right. And then we get late notification that we need to rebuild it again. So having said that, it's really important to add monitoring to the model inference as part of machine learning process. So just going through machine learning, and of course, everything that we have seen on the previous graph was done by data scientists and in manual form. And this is all fine. Of course, in the experimentation phase, we would expect that building, training, and deploying is there. But even with one single model, what we could easily, or the data scientists could easily have as a bottleneck would actually be to have monitoring or to manage it, or in case it needs to be retrained again, it can have a huge impact, so that data scientists then cannot maybe focus on another model, but he has to waste a lot of his time actually managing it, monitoring, and making sure that the quality of the model is where it needs to be. So it stops us from being able to be innovative, and it will also have a huge cost implication from the perspective of maintaining a model, or how much the model costs for us. So have said that, I would like to first see how the architecture looks like without MLOps. So in this case, we have data scientists on the left side, and on the right side, we have AWS account to which data scientist has access to actually Amazon SageMaker Studio notebooks, in this case, Jupyter notebooks, where he can write code for actually making some models, do training, pre-processing. Of course, he has access to the data sources, in this case, Amazon S3, Redshift, Glue, just to name them few. Of course, there are many more data sources that can be used for training. And after he's done with the training inside a notebook, the model itself that is trained, so the artifact, would be saved in S3. So far, so good. Unfortunately, according to Gartner, only 53% of all POCs that are made for ML make into production. So in this case, we might think of that for all of those where it fails, it might be due to the misalignment between the data scientist and the business needs, or in some cases, it could be just as simple as not being part of the whole process of the legal, so that by the end that model is created, legal comes and says, for example, you cannot use this data, and it was not involved in the first place. Or it could also be between the data scientist that is building a model and maybe ML engineer or DevOps afterwards that needs to take care of deployment, that basically they're not in sync, so that this just stopped working. But let's say that we are on the happy path. So we are in that 53%. What will happen afterwards would be that the data scientist would actually deploy this model on SageMaker endpoint, for which the end customers will be able to consume using API gateway requests that would then invoke Lambda, as then that would invoke inference on our SageMaker endpoint. Of course, this is simple experimentation phase, but in this case, if we would put this in production, we would see that actually we have a few issues with this. The first one is that any change need to be done on the model requires manual labor. So the data scientist is actually the one that needs to start working on this right away. The other thing that is the issue here is the actual code. As I said, the code is inside the Jupyter notebook, which means that somebody actually needs to go inside the notebook, change the cell, restart again, and then once they are happy, they would need to save that model artifact inside S3. After that, we said that data scientists deploy this on SageMaker endpoint. Maybe he forgot auto-scaling to be turned on. So in this case, our end customers, in case we would have a flood of requests due to the more customers at some point, our endpoint will not be able to cover all of that. So either it would introduce some delay latency or maybe even out of service. So by the end of it, we also have one big missing point, and this is we don't have any feedback or model performance, as I said, as part of having monitoring and debugging as a really important part. So in this case, we would get from the end customers once our model or service really starts to degrade, and then they would communicate to us while the damage is already made. In case, for example, maybe auto-scaling, it could be maybe one event, but just having in mind that maybe our model quality really degraded, it could be just weeks after we find out from someone that's actually not performing well, so that we need to do retraining again. So with that, I will just want to say a few words about MLOps. So the MLOps is basically operational practices, really similar to the DevOps. It's around standardizing how we are actually doing machine learning, building, training, deployment, governance out of view. In the end, what we expect from it is that we have better productivity and that the model accuracy will be a lot higher, as we don't need manually to retrain it every time. So we have more possibilities to have this part automated. And the last but not least, to enhance our security and compliance in case for some models. And now recently, this is even more, I would say, hot topic is how secure are these models in way of also some compliance around AI. In the end, today we are going to cover the technologic part or technology having for the MLOps, but there are also two other parts which are really important. So from one part, we said it's operational practices that makes MLOps, but these practices or processes in this case needs to be followed by people. So in end, to have a proper MLOps setup within your team, it will require first people that would like to follow these processes that streamline, and technology here only plays as enabler. So from our premise, it's always good to first talk with the people, define processes that people want to follow, and then by the end, use technology to actually apply all of these processes and people. As you can see, it's really small intersection between all of three, what we call MLOps, but it is actually crucial to have all of these three things. But we're going to cover now technology part. So with that, I will just go through our small MLOps architecture. So basically, this is good fit for 1 to 3 data scientists that have a couple of use cases, so that it's easy to be managed. As with the diagram before, so we have actual data scientists still access to the Amazon SageMaker Studio notebooks, still has access to the data sources, and the model is saved in S3. In addition to that, what we're going first to do, we are going to take out the code from Jupyter Notebook and have it versioned inside AWS Code Commit, which is our Git repo. It can be any other Git repo, just for simplicity here, we're using AWS Code Commit so that we have versioning of the code that data scientist is making. And with that, we are enabling collaboration between multiple data scientists. And in addition, for all of the environments where we are actually training the models, so the Docker containers, we would actually store them inside Amazon ECR, which is Elastic Container Repository. You could also use other repositories for containers. But basically with this, we are making it possible so that we can actually automate all of this process. So with that, I'm going to introduce Amazon SageMaker pipelines. So in this case, the pipeline is actually just a set of steps that are required to actually build a model. So it could include, as you can see here, for example, pre-processing job for the data, then training job for the actual model. It could also involve invoking some other code like Lambda or Amazon EMR. For some others, of course, you're not forced to use SageMaker pipelines. You could also do this with some Airflow or maybe with some step functions. But just in this case, our best practices are to actually use Amazon SageMaker pipelines, as they are intentionally made for the model training. And in this case, we can trigger, or data scientists can manually trigger the pipeline to actually build the model. After that, we can also add that the model can, or the pipeline itself can be triggered by some scheduled trigger. For that, we can use Event Bridge and use it more like a cron part, where we can say, for example, rebuild this model, I don't know, every week. This again depends on type of the model you are making. For example, in this case, I would imagine that every week you get new data. So based on that new data, you will get like a weekly update of the data. You would want to build a model that will be most accurate for the next week. So with this, you could automate that the model is built every week, and the data scientist would literally have to do nothing with this when it comes to the scheduled one. With that, afterwards, I'm going to introduce the SageMaker model registry, and we're not actually going to store the model over there. We're just using model registry as a metadata layer on top of S3. So the model will still be saved in Amazon S3, and we're going to tag that path and a bunch of other metadata, so including hyperparameters and some errors or accuracy, or any other custom values that you want to save for the model, and store them in Amazon SageMaker model registry. Besides just storing it there, we could actually, or data scientist or data scientist lead would be able to actually approve or not approve a model that has been built either by manually or by automatic trigger. And with that, regarding the deployment itself, we would still deploy. This might look a bit different than the one before, but basically the SageMaker endpoint here is just inside autoscaling group. So it means that it will autoscale based on the request that we are getting. So in case we have a flood of users trying to access our SageMaker endpoint through API gateway and Lambda invoking, we will be able to scale up and then scale down after these requests start to go down. Just regarding the deployment part, we would also want to automate this. So as I said, SageMaker model registry, we can actually approve model. And after we approve model, we can initiate event that will go to AWS Lambda, which would actually then trigger the deployment on SageMaker endpoint. With this, we have a nice thing where actually SageMaker endpoint will have zero downtime, so that model will be replaced really instantly. And with that, we can also use one additional feature. Actually, we can use canary deployment. Canary deployment, we can think about it as we're, for example, deploying a new model. And ordinarily, it would be like just a big bang deployment, which means just replace model A with model B. With that, we are risking potentially on production, especially, that maybe our model is not performing or working the way that we intended. What canary deployment is actually doing, it will deploy model A as it was already deployed, but model B will also be deployed, and it will just take 10% at the beginning. Of course, this is something that you can configure, but say by default, it will take just 10% of traffic going to it. And if any error happens with our new model deployment, we would receive Amazon CloudWatch alarm. So with that, we would be able to see that something is wrong, and we would be able to act really easily to roll back to the previous model. So do you have any questions so far? Something that's not clear? I'm more than happy to clarify. Okay, I would take silence as a no. So we'll continue. So once your team starts growing or you have several use cases, we would then switch to the medium MLOps architecture. In this case, it's suitable for 3 to 10 data scientists. So this would give you like a good start for when you're heading with more models to maintain. So we will start again with data scientists having access to the Amazon SageMaker Studio, to the notebooks, exactly the same. We are using code commit for the code artifacts and ECR for the, okay. So yeah, there was a question besides canary deployment. Yeah, you could use, so besides the canary deployment, and this again depends on what you want to do when it comes to the deployment. So the blue-green would be type of where you would like to have both of them at the same time. So it's actually a good fit if you are doing, I would call it more A/B testing. But while the canary will just have a more easier rollout going by percentage, and you could then follow how it is going. I hope that answers the question. So if there are not many more questions, I will just continue. So in regards to the model artifacts, everything is the same. We're going to introduce back Amazon SageMaker pipelines as we had before. So everything is pretty much the same. After a pipeline is executed, it will save the model artifact into S3. And after that, of course, we're going to save also the model inside the SageMaker model registry. And we will be still able to have scheduled trigger of the pipeline using Amazon Event Bridge. The part that we're still missing is the part on the deployment part. So the deployment in this case would be another AWS account inside the production account. We are still using auto-scaling group with SageMaker endpoint, Lambda to actually invoke it using API gateway toward our end customers. But the difference here is that actually we are going to rely on using a multi-account strategy, which is something that we always advise to our customers to use. As in this case, data scientist doesn't have access to the production account, so the vector of actually making some manual mistake is really, really low. And with that, we make sure that reliability of our service is actually functioning. Even in case data scientists will do something wrong inside the development account, it will not affect the production account. As compared to our small architecture, data scientist has access to everything, and it could be just a human error while doing something that it could affect a production account. But in any way, we would like that our data scientists or testers have some. Marin, you just joined. Do you have a question?
No, sorry, I'm just testing. There is a lag, and there is. So yeah, I'm just checking.
Okay. Sure. Okay, with that, for the data scientist to have access to it, we're going to have another deployment, and it's going to be the staging account. So in this case, we're going to have exactly the same deployment of the model over there, where the tester or data scientist will have access to actually check the service, how it is working at that moment before we are actually going to deploy it on production. So the part that is missing here now is how does actually deployment works. So for this, we would actually utilize AWS Code Pipeline and use CloudFormation stack sets for both of these deployments. And for this to be triggered, we would actually use Amazon SageMaker. Once we approve our model, it would initiate event, and we would be able then, with that event, to trigger a code pipeline. Of course, in this case, we would first deploy on the staging account, and then after the staging account, we would deploy on production account once our testers or data scientists are happy with how the model is performing. So here we have still some space left. And what the important difference between the medium and the small one, and of course, you can take parts of these features and bring it to the smaller one. You don't have to take everything, including multi-account organization. The part that we're missing, for example, is here the monitoring part. And with that, we will first start with data capture on the SageMaker endpoint. With that, we will have all input and output of all requests that have been done either by testers or by real users on production. And for example, in case we would have all of the data that is needed, we could already do some of the monitoring on the staging or production account. But just having in mind that in reality, we all know that there is some additional labeling or data integration needed before you can compare your baseline and what's on the data capture. We're going to use the data replication inside our development account. So we are going to replicate all of that data inside Amazon S3 bucket for that. And as I said, we need some type of baseline. And for this, we can easily add additional step on Amazon SageMaker pipeline to actually produce this baseline for us in a different Amazon S3 bucket so that we can see, for example, what is actual expectation from our model to behave. With that, we can then point both of this bucket inside our Amazon SageMaker model monitor, which is a service that can create reports on data drift and model drift. So in case we have a really big difference between what we expect model to behave and maybe how it is behaving on production, it could then issue another event to Amazon Event Bridge that we could then use to either trigger SageMaker pipeline again, or in this case, maybe also send a notification using SNS to data scientists that there's actually something happening where they might need to obtain more data or use different type of machine learning model or algorithm when they're building it, so that in the end, you actually detect all of these changes right before even your end customer notice that something is off. So this is why this is really valuable, especially for production workloads where you don't want that your end customers suffer, because as I said, the models change all of the time, and the accuracy that you have on the time when it's built versus what it might be in an hour or in a few days or weeks might differ, and you would want to be able to catch if something like that is happening. So just having in mind that there is some sync issue over there, I will just give a few minutes for questions.
YouTube video is lagging for about roughly 30 seconds. So yeah, but that's how it goes. So one question from my side. When you're talking about multi-account approach, this seems already quite complex in terms of multi-account approach. So is this possible to automate all this process and create, let's say, a setup for the let's say enterprise who would immediately go to this model instead of the earlier ones that we have seen?
Yes, so that's a good question. So just to mention, so all of these accounts, of course, you would use AWS organizations to manage all of them. So in this case, I would actually recommend to have some type of landing zone where you would actually use to create all of these accounts. We do have some SageMaker templates for the MLOps that can actually then be used to be deployed on all of these accounts. It's a bit different. I would call it maybe even more advanced than what we are going to go through now. But in the end, that will be like a perfect solution for having like separate accounts for separate things, and also utilizing landing zone that would be able then to provision all of the policies and roles that are needed, because here we didn't touch upon that. We were just going through having in mind that IAM roles and everything around it is set up correctly. But yeah, I would suggest to automate also this part. But again, I would just say it depends on the number of teams that you have. So if you have only one team, I would maybe definitely start with a small one and then work toward this one. While if you would tell me, okay, we have 10 teams that are working on 500 different ML models, then I'm fully onboarded to have automated account vending for each business case, and to have some automated way of providing access or a set of accesses to different teams so that they can easily work on the training the perfect model versus to actually have I would say infrastructure work. That's actually not the point for the data scientist at all. Is there any more questions?
Okay. Yes, but just I have to wait because of the lag. So when we're speaking about the landing zone, would this be considered as, let's say, a workload of a landing zone?
So the workload here, it can be different things. I will just start maybe. So if you are building maybe multiple models that are homogeneous to one business case, I would rather split them per business case than, for example, per each model that you're building, because we know that some customers start building 200 similar models that are maybe for different regions or different products that they are having. But in the end, the process itself, so the pipeline is pretty much the same. So in that case, I would say just use the single one. While if you are maybe more concerned that these models, that each of these model needs to have its own, I don't know, perfect environment, means of having account that nobody else can affect it, then I would then split them. Again, this is decision that I would say it comes to the organization, how they want to treat it. If they find that all of the models are in the same production account, then I would just use per business case. In case the same business case requires different models, so that you want to be sure that they are up and running, even though one goes down, then maybe in that case, I would use multiple accounts for each of the models.
Okay, perfect. David has a question.
Okay. How often do you use SageMaker Autopilot? So I think this would again, this depends on the business problem that you have. So where we see that Autopilot is mostly used is either to try to have experimentation phase done automatically, so that maybe you can figure out which algorithm or which type of parameters are best to be used, while just using the regular SageMaker and doing training on your own is also a possibility after you found out, for example, which algorithm was best according to the autopilot. Again, here we have SageMaker. Of course, you could also automate these, not just for the SageMaker, you could also automate for a bunch of AI services that we are providing. So whenever it's around having some data, doing some pre-processing, then processing and training, this can also be part of the pipeline. If there are no more questions, then okay.
Perfect. Thank you. Okay, so let me just shed some light because somebody may not know what SageMaker Autopilot is. Basically, SageMaker Autopilot is tuning the model by certain parameters. So basically, you can provide multiple parameters, and based on that multiple parameters, your model has been trained simultaneously, and then it selects which one is the best performing model. And based on that, you don't need to do that manually. Basically, that's the autopilot. Let me know if I have said that correctly.
Yeah, that's correct. Okay, so I will then continue. So basically, once you are having a lot more use cases, so as Marin asked about, once you would go for actual having the vending machine for the accounts and everything, this is when you have multiple teams that are working on a lot of business use cases. So for this, we're going to even more shrink our diagram. So basically, data scientists in this case have only access to the Amazon SageMaker Studio in development account. Of course, Jupyter notebooks, S3 for storing artifacts, code commit for versioning the code. And in this case, to access the data, this data would be then in a specific account. So in this case, this is data account, or it can be data lake. With bigger organizations, they tend to actually store all of their data in specific account that has fine-grained permission sets. So basically, the data scientists that are working on one business problem have only access to the certain type of data that is allowed for them, so they cannot access everything. And with that, it's also easy to actually manage the data governance, so that you can make sure that the data scientists are also having some access to the data. As all of the data is stored over there, there are no data silos in that regards, so that you can just easily, by providing a permission, make them available to some data. With that, I will return back our pipelines, but in this case, it's going to reside in operations account. So operations account is, imagine that we are going to place everything inside that actually doesn't require any human being to trigger anything or to do anything, except, of course, to deploy stuff over there in the first place. But after that, there is no need for data scientists to have access to this account. So as before, we have Amazon Event Bridge that will be able to trigger out a SageMaker pipeline. After that, after a pipeline executes, we would, of course, register our model inside a model registry, and we are going to put our model inside Amazon S3 bucket. But in this case, we're going to have artifact account for this. And we are considering also that even the model registry is an artifact. So in this case, what we are doing, we are preventing that the data scientist is actually able to change a model artifact before deployment on production, or even after it is deployed on any systems. So we are kind of creating a perimeter between what's actually part of building process versus what's the part of producing these artifacts and deploying them on production. So after that, of course, we still have our production account and staging account that look really similar as we had in the previous architecture. And the actual deployment of these CloudFormation stacks are executed with the code pipeline. Just in this case, we're also going to put a code pipeline inside CI/CD account. And we are doing this because before we were thinking that, for example, the data scientists would also be in charge for triggering this. here we are more considering that ML engineer or data scientist lead would be the one, maybe one out of many teams that would be in charge for this, so that he would be able then to execute this code pipeline. In addition with that, of course, we're going to automate it so that Amazon Event Bridge, after the model is approved, will trigger code pipeline. And we are going to return our Amazon ECR for Docker images. And we're also going to put them in artifacts, as we all know that in case we are putting different packages inside containers, we should also consider them as artifacts, as in case something changes over there, our whole build or training model can be totally different. So we also need to take care that our containers are considered also as an artifacts in this case. But also it's different that we don't expect any more data scientists to actually build those containers. So for this, we would actually use also code pipeline, but including a code build that will be also triggered by either ML engineer or data scientist lead that would actually write a Docker file, or that would be actually managing all of this, so that they need to actually understand what changes they're introducing inside a container, as we expect that containers would be reused multiple different projects or maybe different teams. So with that, we're still missing a few pieces so that we have a complete picture. So one of it would be to first have data capture back, and then again data replication for the part of monitoring, so that we will be able to see if we have any model or data drift. Again, we are going to have a baseline produced as part of our SageMaker pipeline, and then we're going to feed that into our SageMaker model monitor that would then issue data or model drift event to Event Bridge for retraining a model again. What's a bit more important part when you have a lot of teams is the actual SageMaker feature store. The SageMaker feature store allow data scientists to actually store features that they engineered, and it also allows them to actually reuse them. If you remember from the first slide where we actually went through the whole process, that whole data gathering, processing, visualization phase takes around 80%. And if you have even multiple use cases, but relying on the same data, there is a good chance that you would want to reuse certain features that were built by other team. So with this, if the data scientist can actually reuse a feature that was already created, he saves a lot of time, and it makes or enables them to move really, really fast. So with that, we would use SageMaker feature store for storing all of the features that the data scientists are creating in order to be reused. And of course, they would be then used inside the SageMaker pipeline for actually training a model. In addition, we can also leverage another service, and you can see it from my video picture, but it is SageMaker Clarify. So basically, we will provide the same baseline and the same data capture that we have. And what SageMaker Clarify enable us to do is actually to have bias and explainability report. So basically, we would be able to have certain drifts, either on bias or explainability, that could, again, trigger a SageMaker pipeline to start rebuilding a model again, or to notify data scientists or data scientist lead or whoever is in charge once this is detected, in case we think that just rebuilding it will not solve the problem. So are there any questions? I will wait a minute.
Not right now, so I think you can continue.
Okay, sure. So just going with that, we did talk a lot around SageMaker. So SageMaker is actually a set of a lot of different tools that are made to work together with other AWS services intentionally for creating and managing models. And with that, it actually makes it for your data scientists to actually just focus on the actual model building and training, so that they can experiment and have better quality overall regarding the models. And in the end, it also allows, which is also important for data scientists, to have automatic lineage for the code and the data, which once you have maybe better results, you want to see, okay, with which data this was built on, which parameters, or which type of algorithm was used for those, in case you're training multiple models every time, which also can be strategy, and just picking one that has the best accuracy or the smallest error rates, depending on your business case. So basically, it's really nice way for the data scientists to be able to interact with services and enable them to move fast. In addition, or I would say the most important part of the whole thing is that MLOps is a journey. So we have seen 3 different architectures, starting with small, medium, large. What this means is that I don't recommend, in case you are in initial stage, to go with a large setup. What could be the case is that you want maybe to introduce SageMaker Clarify or monitoring really early in your project, and that's perfectly fine. What I would not suggest is that, for example, you just go and start a multi-account strategy, even though maybe you are in experimentation phase. Why I'm saying that, because in that case, the data scientist, and I would imagine it would be singular or maybe few of them, would take a lot of time to actually build up the whole infrastructure. While in case you're moving more towards, I would call it, reliable phase, this is where I would anticipate that you are introducing multi-account deployment, so that basically some errors that could happen or issues are prevented, and you can have better way of testing and monitoring overall. So even if your account structure looks different, these are just samples that we have seen with our customers that are using at the moment. And of course, each of our customers have their own organization. As I said, the people and processes are the most important part to get right. So in case you have a different type of setup with accounts, just think about if you can reuse any of the elements that I showed today to actually incorporate inside your architecture and processes, and that this actually fits with the people that are going to use them. Because in case you introduce too many, I would call blocks over there, like using the large architecture just in the beginning, you might find that people are just using a non-MLOps setup, as we have seen in the beginning, and then you would waste a lot of effort for nothing. While in case you are trying to incorporate with your current processes and with your current account structure and just start making to work, so that you automate a good amount of work from your data scientists, so that they can then focus on making a better feature engineering, or doing better data analysis and data engineering overall to produce better models, then that would be a win scenario for you and for them. As I did promise a few articles, I did create a few links for you to check out. We have a few white papers on the MLOps. There are also some solutions and trainings. I could recommend you to go through and see some of them. We have a really, at least for well-architected framework, you might go and see what it would look like well-architected. Again, if you're in experimentation phase, don't take everything that you need to implement everything that you have seen today. It's mostly what makes the best fit for your current stadium. So in case you're in the beginning, just try to incorporate as much as it makes sense. In case you're in the middle, maybe start thinking of how it would look like. Maybe now you have 10 models, how it would look like if you would maintain 25 by the end of the year. or that you have maybe scaling with multiple teams. So how would that look like? In addition, we also have AWS Skill Builder with more than 500 digital courses that you can just visit. And if you like session today, we also have some AWS certifications. For example, I will call for the Solution Architect Associate certificate in case you're thinking to go with that, or Machine Learning Specialty certificate, as this would mostly match with what we covered today. And again, I would like to thank you today for your time and questions. And of course, if you have any more questions, please ask them. And I would also like to ask you for a favor in the end, if you can, please give a feedback. It should not take more than a few minutes of your time. And it really means for us to know, do you like the content, and would you like to have more sessions, maybe in depth, or maybe even more high level.
Okay, thank you very much, Stefan. I have vouchers again. I got them today. So would you like to ask a question from your presentation? So somebody from the viewers may get one, or we can give one to David, who who asked the 3 questions, I think, and he was active even on the previous one.
I'm fine with taking for David. He's really active one. So
yes, absolutely. So David, you're getting one, that's for sure. Okay. David has another question that we have skipped, or he just asked it.
So can you clarify more around what it means to be data-centric or model-centric approach? Okay, so yeah, thanks for that. So basically, I would always go for the data, that the quality of the data needs to be on the best. I mean, of course, maybe you can build a good model even with not such good data. But for having more accuracy, it would actually require that you have better quality of the data, or maybe it's that you need to have different data sets for the data. So it could be that you are just not having enough information. So what I want to say here is that, for example, regarding the data gathering, it's actually also like a process. It's not like one-off. You have the data. It's also when you analyze and maybe you think, okay, I don't have enough data, as for example, enriching the current data sets with trends and stuff might help for certain model trainings, or gathering a different data set for the business problem that you are solving that you might not think even in the beginning. But if we would say that, for example, this is the data that you have, and then you cannot do much around it, I would then be more focused on the model, like you asked. So as much as you can get a better quality of the model. But I think in the end, I would expect that data engineer would try to get the best quality out of the data, while, for example, the data scientist, I would expect to try to get the best out of features and the model itself.
So it seems that everybody has its own responsibility, I guess. So the data scientist needs to do to prepare better data, while the AI guys need to focus on model, as I understood.
Yeah, basically, like in DevOps, we have owning model from all of the perspective, but we have different roles that are in charge maybe for developing the code. But of course, they own till the end. It's also here that, for example, data engineer, data scientist needs to work together, including ML engineer, for example, for production, because maybe they are using some different type of frameworks or libraries that are not behaving so well in production. So I think everyone needs to work as a one team. And the difference between the DevOps, at least from my perspective, MLOps is more harder to do as it involves more people and requires more streamlined processes so that everyone can work together and produce a better service for the customers.
Okay, thank you very much. Okay, if there are no more questions, we can wrap it up.
Thank you, Stefan, for the great
some questions
presentation.
from the people in the room? I think we are okay here.
So in case you have any other questions around MLOps or SageMaker, just please reach out either on LinkedIn or to Marin and Jenan, and they know how to find me. So
Okay. Perfect. I think we can wrap it up. And thank you very much, Stefan. It was a great presentation as the previous one. And let's have something similar again in the future.
yeah, sure. And I hope we also have on-site one.
Absolutely. Looking forward to that. Jenna,
thank
you very much also.
Have a great rest of the evening, Mario.
You
Thank
too.
you, Stefan. Bye.
Bye-bye.